Good morning, students. In this class, we are going to discuss about basic concepts of algorithms. That is, what is an algorithm? What are the properties of an algorithm? How to develop an algorithm? That means phases in this algorithm. Then after, how to analyze the performance of an algorithms. So first, go to what is an algorithm. An algorithm is a step-by-step procedure used to solve the given problem. In generally, algorithm must be completed in a finite amount of time. That means the algorithm must have finite number of steps, and each algorithm must be produced one output, and at the same time the user need to pass zero or more inputs. Next, coming to the properties of an algorithm. So there are three properties an algorithm need to be fulfilled. First one is definiteness, and second one is effectiveness, and third one is finiteness. So definiteness, coming to the definiteness, definiteness, it describes that there is no ambiguity in the expressions or instructions of the algorithm. Each instruction should be clear and unambiguous. That means each instruction perfectly specified without any ambiguity. For example, if you see here an instruction add 6 or 7 to the variable x, there is a ambiguity. Means can we add 6 or 7? There is no clarity or there is no specific instruction. Such type of instructions are called ambiguous instructions. So that definiteness means avoid such type of instructions. So it is definiteness achieved by implementing the algorithm in any programming language, because all the programming languages must have unambiguous instructions. A instruction implemented in any programming language must have the clarity and unambiguous. That's why definiteness is achieved by implementing the algorithm in any one of the programming languages. Next property is effectiveness. Effectiveness means how much the algorithm is effective, how it is efficient, how much it is efficient. Simply, we say that it is easy to carry out the evaluation of an algorithm using pen and paper for the user. So here we take one example. Perform arithmetic addition of integers. It is easy to perform integer addition using pen and paper, but whereas perform addition using pen and paper on real numbers, it is not easy, it is not effective. So effectiveness means the algorithm must be simple and easy for the user to carry out using paper and pencil. Then only we say that it is a effective algorithm. Effective algorithm means easy for interpretation, easy for interpretation. Based on the sample input data, we can easily evaluate sample outputs using paper and pencil without implementation on computer. That is called effectiveness. So coming to the next property, finiteness. Finite means limited or less number of steps. Every algorithm should terminate after a finite number of steps. That means every algorithm take finite amount of time for its execution. It is another property of the algorithm. So finally, an algorithm is said to be a good algorithm or a optimal algorithm when it possesses the following properties. The properties are, first one is when it works correctly. Correctly means when it produces the desired output, then only we say that it is correct one. And readable, so readable means there is no ambiguity, it provides clarity and understandability, that means definiteness. And efficient in terms of time and memory utilization, that means effectiveness property. So an algorithm which possesses the three properties, definiteness, effectiveness and finite, then only we say that it is a good algorithm. So now we are going to discuss about development of an algorithm. The algorithm development process have four steps. First one is device. It is a design phase. Design an algorithm using any one of the design paradigm. Then after we validate the algorithm, validation phase. After that, analyze the performance of an algorithm. It is also called as analysis phase. After that, we implement the algorithm in any programming language and measure or test its performance. It is called testing phase. So now we are going to discuss about these phases in a clear way. First one, devise the algorithm. It is also called design phase. To design an algorithm, we follows any one of that algorithm design paradigm based on the problem context. There are basically two types of design paradigms are available, static and dynamic. Static design paradigms are applied to the problems which have static input and outputs. That means static input means the input not changed during the program execution, during the algorithm execution. Such type of problems are called static problems. To solve such type of problems, we use static design paradigms. Static design paradigms are divide and conquer, greedy method. These two are the static design paradigms. Dynamic problems means the input can be changed during the algorithm execution. Such type of problems are called dynamic problems. To solve such type of problems, we follow dynamic design paradigms. Dynamic design paradigms are dynamic programming, backtracking, branch and bound. So in this way, in the design phase, we select any one of the paradigm which is suitable to execute to find the solution. Based on that paradigm, we develop the algorithm. After that, once the algorithm is designed, we need to validate whether it is correct or not, whether it is produce desired output or not. That is called validation of an algorithm. An algorithm need to be validated to determine its correctness. Next phase. analysis. Once the algorithm is validated and ensure that it is a correct one, we need to analyze its performance. That means even though it is correct one, it is not a best one. Even though an algorithm is correct, it is not a best algorithm because its performance is worst. Okay, so we need to analyze the performance of algorithm to determine whether it is the optimal one or not, to determine whether it is the efficient one or not. So for that purpose we use best case, worst case and average case. Algorithm analysis describes the performance of an algorithm in three cases: best case, worst case and average case. Best case represents the optimal or minimum number of steps required to execute the algorithm. Worst case represents the maximum number of steps required to execute the algorithm. Average case represents average number of steps required to execute the algorithm. So algorithm analysis mainly used to compare any two algorithms and find the efficient one. Similarly, it is used to determine space complexity and time complexity of a given algorithm. Once the algorithm performance is analyzed, we implement it in the computer in any programming language. After implementation, we test its performance by perform the two tasks, debugging and profiling. Debugging means detect errors in the program and correct them. If an algorithm have bugs, that means runtime errors. Debugging means error detection at runtime. So bugs, the errors occurred at runtime are called bugs. So bug detection is a process of debugging. If an algorithm produce more number of bugs, then its performance is worst. In that way, we test the performance of an algorithm with the help of debugging. After that, if there is no bugs or if there is any bugs, those are also detected and corrected. We go for profiling. Profiling means simply run the program using sample data and record the outputs. The recorded outputs are equal to the expected outputs, then we say that the algorithm is a efficient algorithm and it is also produce the desired results. In that way, the algorithm development have four phases. First one is design, then after validation, after that analysis, after that testing. So next, performance analysis. Algorithm performance analysis mainly divides into two types. One is prior analysis and the second one is post analysis. Prior analysis, as the name implies, the performance is analyzed before implemented in any programming language. It is also called as performance estimation. Post analysis, as the name implies, it is performed after the algorithm implemented in any programming language. It is also called as performance measurement or performance testing. So Generally, we perform prior analysis only. So to perform prior analysis, it is based on two criteria. One is space complexity and the second one is the time complexity. So based on these two criteria, we evaluate the performance of an algorithm or compare the performance of given any two algorithms and find the best one. So space complexity, the amount of memory an algorithm need to run to completion is called space complexity of the algorithm. The space complexity of an algorithm consists of two partitions, fixed part and variable part. Fixed part means the space required to store fixed part of an algorithm. Fixed part of algorithm means it does not depends upon instance characteristics of the algorithm and its size is not changed during the execution of the algorithm. Variable part, as the name implies, its size is changed during the execution of the algorithm and it depends upon instance characteristics of the algorithm. The constants and simple variables instructions comes under fixed part of algorithm. Reference variables, arrays, pointed arrays, or stack address space of a subfunction or procedures or comes under variable part of the algorithm. So the time complexity of an algorithm S of P is equal to C plus SP. Here C is the constant represents size of the fixed part. SP represents the size of variable part. So the change in SP can do the changes in S of P. That means the change in the space required for variable part also do changes in the space required for the algorithm. So the space complexity of an algorithm varied with respect to variation in the variable part space requirement. Here we take one example simple algorithm ABC. Here the algorithm returns some arithmetic operations on ABC. Here there is no instance characteristics, all are simple variables and all the simple variables are ABC. On that simple variables we perform some arithmetic operations. There is no dependency, there is no instance variable. So here the variable part is 0. So space complexity of the algorithm is equal to fixed part space plus variable part space. Here the variable part SP is equal to 0, so that the fixed part is equal to C. So finally the space complexity of an algorithm is equal to C. Next we take down another example. The algorithm sum return summation of n elements in the array A. In this algorithm, the variable s initialized to 0 and the for loop repeated up to n times. In each iteration, it performs addition of an element to the variable s. S is equal to s plus a of I. Finally, after summation of all the elements, it returns yes. One word for each integer. Here, the space required, we assume that one word for storing one variable. So here, how many variables? I is one variable, S is another variable, and the starting address of array A is also takes one word to store n, one word. So n, I, s and starting address of array A. So totally it requires 3 words, and the array A requires n words because it need to store n elements. So its space complexity is n plus 3, n words for the array A and 3 words for the variables n, I, s. Take down another example. The same program, summation of n elements of an array using a recursion or sum. Here first we verifies n value. If n is less than or equal to 0, that means the array contains only one element, return a of 0. Otherwise the array contains more than one element, then a of n plus r sum of a comma n minus 1. That means the value of nth element plus sum of n minus 1 elements. It is instance characteristic. Here it is depends upon the value of n. The value of n. So in each recursive procedure call, it need to store the values of array starting address n and stack return address space. So requires 3 words. Totally the recursive function calls n plus 1 time, n plus 1 times, so that its space complexity is 3 into n plus 1. Its space complexity is 3 into n plus 1 because the recursive function called itself n plus 1 times, and in each call it requires 3 words, one for storing the array starting address A and another one for storing the variable value n, and the third one is store the return address. Next, second criteria is time complexity. It can be defined as the amount of time required to run to the completion of an algorithm. The time complexity of an algorithm is the sum of the time required to compile an algorithm and time required to run an algorithm. It can be defined as time complexity of P is equal to compilation C of P plus a run time required to run the algorithm R of P. So compilation time is independent of the problem instance, whereas the runtime of the problem or the program is dependent on instance characteristics. For example, if you take addition of a two-dimensional array program, here the indexes are 2 by 2 array. It requires to read 4 plus 4, 8 elements only. After that it performs addition. If you perform addition of two arrays whose size is 4 by 4, so 16 plus 16, you need to read 32 elements from the keyboard. In that way, the runtime is varied, but compilation time is not varied, it is fixed one. So that the time complexity of an algorithm mainly depends upon the runtime of the algorithm. So time complexity, to calculate time complexity, we consider only a runtime of the program. So there are two methods to find time complexity of an algorithm. One is counting step or step count method. In this, we count how many number of steps required to execute each expression, and finally we get the change in the count variable. So in this step count method, it follows three steps. One is, before start the algorithm running, declare a global variable count and initialize it to 1, 0. In the algorithm, before executing an algorithm, we need to increase, before executing a expression in the algorithm, we need to increase the variable count by the number of steps required to execute a step in the algorithm. At the end, the change in the count variable is equals to the number of steps required to execute the algorithm. Example. Here in this example, after initialize the variable s, we increment the count value by 1. Next, coming to the loop, after change in the loop variable I assigned to a new value 1 to n, we increase the count value by 1. Then after add the element a of I to the variable s, once again increment the count value by 1. The third one is, after exit from the for loop, we need to increment the count variable value by 1. Finally, return yes. It is also one step statement. So to execute it, one step is required so that the count variable value incremented by 1. Finally, before for loop, count is incremented by 1. After exit from the for loop, count incremented by 1. Before return statement, count incremented by 1. 3 times. Within the loop, there are two statements. Count is incremented by 2. How many times the loop is repeated? The loop repeated n times, so that the time complexity is 2n plus 3. Another example, R sum. Here also, to compare n value, n is less than or equal to 0, it requires one step, so that count is incremented by 1. After that, return 0 0 requires one step, so that count is incremented by 1. If it is not else case, return or sum a of n, a comma n minus 1 plus a of n. It requires one step, so that count is incremented by 1. So next, another method to find time complexity is frequency count method. In this, we construct a table. The first column represents the number of steps required to execute an expression E, and the second column represents the frequency of an expression E. Third column represents magnitude, that means the total number of steps required to execute an expression E. That means frequency into number of steps. Finally, grand total, the summation of frequency into number of steps required to execute each statement, is represents the time complexity of an algorithm. Here, take the same example, summation of elements in an array A. The first statement requires only one step and it is executed only one time, so that for totally it requires 1 into 1 step. For loop, here the loop variable I requires one step, but it is executed n plus 1 times, so total n plus 1. Next, within the loop, the summation statement s is equal to s plus a of I. It requires one step, but it is executed n times, so its frequency is n. So total number of steps are number of steps plus number of steps into frequency. So 1 into n. Finally, return statement requires only one step and it is executed only once, so its frequency is 1. So total number of steps are number of steps into frequency, so 1 into 1. Finally, to get the grand total or time complexity of an algorithm, perform summation the total steps required by each line. So it is equal to 2n plus 3. Another example or sum. Here, the number of steps required to execute an expression is based on the n value. If n is equal to 0, it is if case. If n is greater than 0, it is else case. In case of if case, the first line requires only one step and it is executed n is equal to 0. So its frequency into number of steps 1. Similarly, return 0, it is only one step and it is executed only one time, so it's 1. So in the else case, if n is greater than 0, it needs to test the condition, after that enters into else. So if n is equal to 0 or less than 0, it requires only 2 steps. Whereas if n is greater than 0, it requires 2 plus x, where x is equal to the time complexity of n minus 1 elements. That means the time required to perform summation of n minus 1 elements in the array. So it is equal to 2 plus 2x, 2 plus x. So time complexity. So time complexity of the algorithm is equal to 2 if n is equal to 0. Otherwise 2 plus the time complexity of n minus 1. It is simplified by using substitution method. In this substitution method, 2 plus sum t or sum of n minus 1. T sum of n is equal to 2 plus t sum of n minus 1. Now substitute t sum of n minus 1. It is equal to 2 plus t sum of n minus 2. So 2 plus 2, 2 into 2. After that, next iteration, 2 into 3, n minus 3. So next one is 2 into 4 plus t sum of n minus 4. In that way, 2 into n plus t sum of n minus 1. So n minus 1, n minus n is equal to 0. So t of 0 is equal to 2. Already we know it. Where if n is equal to 0, then t or sum of 0 is equal to 2. If n is equal to 0, the time complexity is only 2. So 2n plus 2. In that way, we find the time complexity using frequency count method. So these time complexity or space complexity are used to measure the performance of an algorithm. So it is about performance of an algorithm, properties of an algorithm, and introduction to algorithms. So thank you.